under the general organic chemistry, we are doing the electronic effects and steric effect. This is the last phenomenon of steric hindrance. It may be shortly defined as the problem arises whenever the non-availability of the space. So, the molecules like to do that or exhibit that property, but just because of there is no space available to approach the reactant or so, the reaction sometimes totally you find 100% not taking place, or sometimes a reaction takes place, but partly takes place like 50%, 25%. Sometimes the reaction instead of that reaction some other reaction will be taking place, that is diverted to give some other reaction. All this the phenomenon whenever you observe just because of the non-availability of the place, that is called space non-availability, is known as the steric hindrance. In fact, we have wonderful examples, though it is a very simple and understanding it is very easy, but it has a lot of impact. Sometimes it dominates the some of the so called mesomeric and the hyperconjugation phenomenon even. Let us take some examples or applications of this particular. The basicity of the tertiary amines. This is the first application. Let us take 3-degree amines here. So, we have seen already the ammonia is containing a pair of electrons. So, therefore, it can donate, and this donation effect, electron donation effect, is called basicity. Therefore, ammonia is base. So, similar the case when alkyl group is attached, like say an example ethyl group attached amine is found to be more basic, because the alkyl groups are known for the plus effect. So, therefore, these amines are found to be more basic than this one. Similarly, the case we also observed that 2 ethyls whenever it is there and found to be much more basic. So, therefore, the basicity order is increasing basicity. It is also found to be correct as per this theory we are expecting, and the basicity also from ammonia to ethylamine to diethylamine, basicity is increased. But unfortunately, when you take a nitrogen with 3 ethyl groups, that is called what? A tertiary amine, 3-degree, or you can say by name triethylamine, a common name however, triethylamine. So, this triethylamine is expected to be much more basic, because originally the lone pair is there and all these alkyl groups are donating, therefore, it is expected to be much more basic. Or if I grade like this, this is 3 degree, this is 2 degree, this is 1 degree. So, expected order is 3 degree should be more basic than 2 degree, than 1 degree, than the ordinary ammonia. This is what expected. But in this particular case, that is when R is equals to ethyl, it is found that the 2 degree is more basic, or in other way 3 degree has found to be less basic than the 2 degree. So, therefore, the what is found is not expected. The 2 degree is more basic, especially in this particular case. The rest is same. The 1 degree ammonia is retaining their order, but in the case of 2 degree, 3 degree, 3 degree is found is expected to be more basic, but found to be less basic. This is explained that the nitrogen, all the 3 sides, 3 alkyl groups are there. So, therefore, a proton approaching this ammonia will have some problem. From this side, definitely there will be a problem, isn't it? So, all the 3 sides, 3 alkyl groups will covering the area, and the proton coming and taking. The donation, this nitrogen cannot throw the electrons to the proton and shows the basicity. That's something different. What we do, the donation of money means we can throw it also, but the nitrogen basicity is defined how best it makes a donation of a pair of electron to the proton and makes a coordinate covalent bond. That bond formation, unless the proton comes very closer, the overlapping of the orbitals and bar formation will not take place. So, therefore, the throwing of electrons is not the criteria here. The proton should come closer to the nitrogen, have a bond formation also, coordinate covalent. That is called defined as a basicity. So, definitely the 3 alkyl groups from the 3 sides it is covering. So, therefore, the basicity what you expect is not found, and the 2 degree, because of the one hydrogen is a smaller one, from that side maybe probably some space is available. So, therefore, the 2 degree is found to be better than the 3 degree. The decreased basicity of the amine is explained that 3 sides, 3 alkyl groups are blocking. So, therefore, the proton approach is becoming a problem. That is what we say it is the steric hindrance is there for the approach of the proton. Okay, we can agree. But if you carefully see the symmetry of the nitrogen, a lone pair will be one side, all the alkyl groups will be, if you cut, that means a line, if you pass like this, all the alkyl groups, though it is big or small, will be one side, and the nitrogen will be on the other side, because that is the symmetry. At nitrogen we have a tetrahedral symmetry. Therefore, a lone pair is almost one side freely it is there. So, there where comes this proton approach will not have any problem at all, isn't it? So, we cannot argue that the nitrogen, this is 3 degree amine, will have really a problem. For this we can have further explanation. This ammonia, it is not a permanently will have this particular structure, because out of the 4 groups, one is a cloud. The cloud can come this side, right, and the alkyl groups will shift to the other side. So, this is called, technically it is called the inversion of the symmetry, or you can say the flipping. It flips into the other, just like after when you are cooking an omelette, after half frying, we flip the omelette the other side. So, the molecule also, the cloud comes this side, the alkyl groups go that side. This is called in one method, it is explained as a flipping takes place between the nitrogen, one side cloud comes the other side. Now, if it is fastly taking place, however, it is not resonance. So, therefore, better you say a fast exchange is taking place, and this if it is really fast, you find like this, the lone pair sometimes looks that side, sometimes looks this side, the alkyl groups will be sometimes look this side, sometimes look that side, right. So, finally, how it looks means just like a rose flower when it is opening, some petals open, still some a bird type of the bird is in the center and some flowers open. Like that it is all these petals are covering the unopened bud. So, it looks like that. So, therefore, approach of the proton, really there is a problem, because all these alkyl groups, when the alkyl group that side, the proton will come closer. The moment when it comes nearer, all alkyl groups will come and the cloud goes that side. So, therefore, really there is a problem that we cannot deny that the half of the side lone pair is there. So, where is the problem means that is not the correct. The alkyl groups are not permanently at one side, it is going on flipping from this side to that side. Therefore, the steric hindrance is really existing. To this extent, we have another example. Let us take one nitrogen attached with it is a cyclo compound. It is right now it is a 2 degree, it is called imine actually, but it is attached with one more group like this. There is all these carbons are there. It is a bicyclo compound. In the term at one of the corner nitrogen is there. Now, there is a lone pair. This lone pair can donate to the proton. Compare this basicity versus another compound with a nitrogen containing a propyl group and a ethyl group and another ethyl group. Now compare these two. These are also having the same number of the carbons. Now why cannot have a argument that it has more carbons, less carbon? Same number of carbon, inductive effect is same. But in this compound what is happening is the cloud can come this side and alkyl groups may go that side, right? So by doing so, what happens if a proton approaches this N and all alkyl groups will go that side and push away, just like a crab will push the other insect if it is coming closer. Like that, these alkyl groups will be moving from that side to this because they are not attached back side. It is open alkyl group, therefore they can flip this side, that side. Whereas here what we have is all these alkyl groups are attached to a common carbon. So therefore in this case there is no flipping. Flipping is not possible. So therefore permanently a lone pair is there. Therefore it is found that this particular amine is more basic than that. So how it is so means we cannot take the help of the alkyl, that is inductive effect, because same inductive effect. Only the steric hindrance, no steric hindrance here because there is no flipping, permanently exposed cloud. Here the cloud is shifting from this side to that side. There is a really the steric hindrance is coming. This particular ring has a common name also called quinoclidin. It is a part of the structure which is then in the quinine, antimalarial drug, has this particular part in that structure. So this is commonly known as quinoclidin. The quinoclidin is found to be more basic than N-propyl ethyl ethyl, that is diethyl amine. Explain means we have to have a clear point here. This has no steric hindrance because all the groups are attached to a common carbon, where there is no steric hindrance produced by here, whereas here there is a flipping takes place, and so therefore steric hindrance is there here, whereas here there is no steric hindrance. So therefore this is found to be a stronger base than this particular example. So therefore clearly established that whenever the nitrogen has got the alkyl groups, not necessarily actually 3 alkyl groups, sometimes 2 alkyl groups very big also will have the steric hindrance. Even sometimes 1 degree amines having a neopentyl group, let us say, sometimes 1 degree will become more basic, less basic than even the 2 degree also. Depending upon the size, we have taken in the previous case ethyl group, in which case the 2 degree is found to be more basic than the 3 degree.